Hi everyone, and welcome back. So today we're looking at unit 6.8. This is area of composite figures. This is page 568 in the textbook. All right, so let's go ahead and take a look at what we're going to learn for today. Again, my voice is still kind of weird from being sick, so sorry about that. All right, so we're going to find the area of composite figures, just like it says up in the title there. Find the area of composite figures. And then we're going to solve problems involving the area of composite figures. Solve problems involving the area of composite figures. Okay, pause if you need to. I'm going to go ahead and move on. Okay, so here's just a little review of our formulas. Okay, so first we have the parallelogram. Okay, remember a parallelogram is basically just any four-sided figure that have opposite sides congruent. Okay, we have a triangle. Of course, we already know what a triangle is. A trapezoid, remember, it looks like this typically, the isosceles kind, which means two of the sides match and then one set of parallel sides. And then, of course, we already know what a circle is. Okay, so we should have learned these formulas in the years past, so it's not really anything new, it's just we're putting multiple formulas together. So if you forgot what something is, just go back and review real quick. Okay, so for a parallelogram, it's base times height. Okay, for a triangle, it's 1/2 the base times height, or base times height divided by 2 is another way to look at it. For a trapezoid, you take 1/2 of the height, and then you times that by your two bases added together, or again, 1/2 means to just divide it by 2. All right, and then for a circle, it's pi r squared, which we just got done learning in the previous lesson. All right, let's go ahead and take a look here. And it looks like my window moved a little bit. Give me just a second here. Oops. There we go. Must have accidentally hit it a while ago. Okay. I know in my copy that the diagrams didn't show up very well on some of them, so if it didn't, just pause it real quick and kind of draw everything in. All right, and I gave you a little bit of helpful hints as we went through here. All right, so we're going to find the composite, or find the area of the composite figure. And so first what you got to do is you need to separate it into smaller pieces. All right, so when you look at your arrow here, when you actually look at it and break it down, what we end up with is a rectangle, and then we have either one big triangle, or you can separate that into two smaller triangles. All right, so in this case, we're just going to separate it into two pieces and make it one big triangle and one rectangle. Okay, so a rectangle is the same as what a parallelogram would be, so we're going to do the length times the width. So the length and the width are 15 and 23. And then we'll add that to what the triangle is. So the triangle is 1/2 the base times the height. So first we'll start with 1/2, so 0.5. Okay, we're going to do the base, which is the whole bottom of it. So that'll be 6, and then this is 15 over here. And then we've got another 6, so 6 and 6 is 12. 12 plus 15 makes 27, so it'll be 27. And then the height is also the altitude, so right here is the height, so how tall it is. Kind of like the rafters in your house, okay, so how tall are they? So in this case, it'll be 8 inches. All right, and then from here, we're going to type the whole thing in at one time. Make sure you've got a TI-30X2S calculator for this one. Your cell phone's not really a good option because it doesn't always follow order of operations unless you know how to really type it in really well. So we'll have 15 times 23, and then we'll have plus, and then 0.5 times 27, and times 8. And we should come up to 453. Okay? So let's take a look. And that is right, so it's 453. And we're dealing with area, so we need square measurements, so it'll be inches squared. All right. Okay, let's look at the next one. So we're going to find the area of the composite figure, and we're going to round to nearest tenth if necessary. All right, so we kind of have what looks like an ice cream cone, or like a piece of a spinner, or like a clock hand, or something like that. Excuse me. So what we're going to have to do for this one is we need a semicircle. Okay, so remember from the circle section, okay, to do a semicircle, we're just going to divide it by 2. So we're going to do pi r squared. So pi, and then you need the radius squared. Okay, so the diameter is 6, so that means the radius would be 3 squared, and then we're going to need to divide that by 2. And then we're going to add that to our triangle here. So our triangle is 1/2 the base times height. Okay, so 1/2 would be 0.5. The base would be 6. And then the height is 16. Okay, so let's type all that in. So we're going to do pi 3 squared divided by 2, and then plus, and then 0.5 times 6 times 16. And it came out to 62.1 millimeters squared. Okay? All right, so if I need to go over this one again, so this is a semicircle here. Okay, so there's my semicircle, and then this part is the triangle. Okay, so remember a semicircle, you find the area of the circle, and then you divide it by 2, and the triangle is, like on the previous one, 1/2 the base times the height. Okay, so the base is like the part that would sit on the floor, and the height is how tall it would be. All right, let's move on to the next part. All right, need another example? Sure, why not? Okay, so find the area of the composite figure, and we're going to round to nearest tenth if necessary. All right, so we got a lot going on here. It looks like we've got a quarter circle. All right, so let's kind of write out what we've got. We've got a quarter of a circle plus, and then we've got a square. And then we've got the big triangle here. So we've got 3 pieces. Let's put triangle there. Okay. All right, so we need to figure out what a quarter of a circle is. All right, so we're going to do a quarter, so it'll be 0.25. Okay, so we have a quarter of everything. And then we need pi r squared. So we'll do pi, and the radius in this case would be 2. And we're going to square that. Okay, plus, and then a square is length times width, so that's 2 times 2, which is 4. So you could just substitute in 4 if you wanted to. Okay, and in this case we need the length or the triangle. So 1/2 the base times the height. So 1/2 is 0.5. Okay, now the length of the base they didn't tell us. They just told us that the whole thing on the bottom there was 4, and then part of the square there was 2. So that means the other part then also has to be 2. So it'll be the base, and then same thing, we gotta go the other way to find how tall the triangle is. So part of the semicircle is 2, and then the square is also 2. So for that one, we would simply do 2 plus 2 to get 4. So it is 4 inches tall. All right, so we got a lot to type in, so take your time here. So we're going to do 0.25 pi 2 squared plus, and then 2 times 2, which is 4, plus, and then 0.5 times, and then 2 times 4, which is 8. All right, we're going to round off to 1 decimal place because it says to nearest tenth, so we should get 11.1. And this was in inches, so inches square. Okay? Okay, let's go ahead and look at the next part. It says a ceiling tile covers 3 square feet. How many tiles are needed to cover the octagonal ceiling shown at the right? Okay, So first we're going to have to find the area of the ceiling by separating the figure into a rectangle and two trapezoids, then find the number of ceiling tiles, all right? So in this case, we're going to do 1/2 of the height times base 1 plus base 2. So for our trapezoid then, we're going to have 1/2, so 0.5 times the height. So the height of the trapezoid is 5 feet. Then we're going to add the bases together. So the top base is 10, and the other one is 18, so that would make 28. Okay, now we have 2 of those, so we're going to do 2 trapezoids. Then we need to do the area of the rectangle here. So we've got, let's see, 18 by 20. Okay, so let's figure this out here. I kind of wrote this out weird. So we got 0.5 times 5 times 28, so that gave us 70. And then we're going to add those together. So we're going to do 70 plus, and then 18 times 20, which came out to 430. Okay, and that'll be feet squared. Okay, so altogether it looks like we've got to cover 430 square feet, and each one covers 3 square feet, so then we're going to divide that by 3 and to figure out how many we need. So it looks like we need I messed up somewhere. Hold on. I got ahead of myself here. What did I do wrong? Oh, I forgot to times it by 2. That's what I did. Okay. Sorry, I need to back up right here. It's not 70. It should be 140. Okay, so one of them is 70, so times that by 2 is 140. There we go. Okay, sorry about that. Misread it there. So times 2 is 140, and then we're going to do plus, and then 18 times 20. I knew that didn't look right. There we go, 500. Okay, that makes more sense. I was going to say, like, it should be a lot bigger than that. Okay, then we're going to divide that by 3. Okay, and then that gives us 166.6 repeating. So let's see, so how many tiles are needed? Well, we can't have 2/3 of a tile, so we're going to need definitely 167 then. So let's see, let me back up here. I'm going to put approximately, sorry. So approximately 167 tiles. There we go. Because we got to have more than enough. Okay. All right, so again, what I did here was I took one trapezoid. All right, that gave us 70. Then I needed to times it by 2. I didn't times it by 2. I just typed it in the first time. So I didn't pay attention there. I thought I hit it, but I didn't. So that gives us 140 then for the 2 trapezoids. Then I add in the rectangle there in the middle, and then I put all those together, and that gives me 500. And then we'll divide that by 3, and that gives us 167. Alrighty. Okay, for number 2, okay, down there at the bottom, let's take a look at this one. We have an L-shaped counter, and it has to be replaced with a new countertop, and it costs $52 per square foot. So what will be the cost of the new countertop? Okay, so we're remodeling a kitchen. Apparently, we need to take out the old laminate. We're putting in something obviously expensive if it's $52 per square foot. So we're going to need to figure out here how much this new countertop is going to cost. Okay, so you can kind of bisect this in 2 different ways. You can either do a vertical slice down there and cut it off that way, or you could do a horizontal slice. So it doesn't make me a difference. It's all still going to come out the same. So I think for me, I'm just going to cut downward here. So that means if this is 2, then this is 3 feet. Okay, and then we'll go from there. So for the first rectangle, it's going to be 3 feet. by, and then we have 2 plus 3, which would be 5. So we're going to have 15 feet for that part. Okay? Now, 10 feet is for this whole thing across here, so I need to figure out what just this part here is. So if I look at the top part was 3, which means that this part here then is 7 feet. Okay? So we're going to have a 7 by 3 section also. So 7 by 3, so 21 feet. Okay, so we're going to have 15, and then we'll have plus 21, of course, and that makes 36. Okay, square feet. Okay, so if I need 36 square feet of countertop, and it's going to cost 52 per square foot, so we're going to times that by 52 then. Yeah, so it's going to be expensive. Okay, yeah, we're looking at $1,872 for your countertop. All right, so if your parents haven't put in one of the higher end, either like quartz or granite countertops, this is why, because even a 36 square foot section, which is not very big, will cost you almost $2,000. So very, very expensive to replace countertops. Okay. Next, we're going to replace some carpeting, it looks like. So it says carpeting costs $2 a square foot. So how much will it cost to carpet the area shown? So we got our rectangular piece there, so that's 14 by 10, so that's easy enough. Okay. Then I got my little square there, so it's kind of like a hallway or something or other there. So that's a 3 by 3 section. So that would be 3 by 3, which is 9, so that's easy enough. Plus, and now you gotta do the triangle. So the triangle is 1/2 base times height. So the base right here will be the same as this one, so that's the same there. So that's still 14. Okay, so 1/2 of 14, and then times the height, which is the 12. Okay, so we have 140 here. We've got 9. And then let's see, half of 14 would be 7. 7 times 12 is 84. Kind of simplify a little bit there. Okay, so we got 140 plus 9 plus 84. And it looks like I got 233 square feet. Okay. All right, so our carpet's going to cost $2 a square foot, so we're going to times that by 2, so we're just going to double everything. So that's $466 to recarpet that one part there, okay? So when do we use this in the real world? When we're building houses or remodeling whatever we already live in, okay? So if your parents have done any remodeling and you've gone through it, you know it gets a little bit crazy around the house. So there we go. All right, let's go ahead and move on. And nope, I guess that's it. Okay, so thanks for watching, and I'll see you guys next time.